Hello everyone. So in our previous lecture we discussed about inertia. So in this lecture we are going to discuss about various laws of motion. Now before starting the laws of motion, you must know what actually force is. So force can be defined as an external cause that changes or tries to change the shape and position of a body. Now, let's see, suppose we have a body which is placed on a surface like this. Now, if you apply force F, then this body starts moving. Now, the body moves in the direction of force. Okay, so what are the effects of forces? A force can start the motion, or it can start the motion of a body from rest to motion. Second one, a force can stop the motion. Suppose the body is moving and you apply force in opposite direction, then you can stop the motion. Force can change the shape and size of the body. Fourth one, force can change the direction of the body. And fifth one, force can also rotate a body. Just like suppose you have a rod and you hold this rod between these two fingers and then apply force in this direction. So this rod will start rotating about this fixed point. So these are the various effects of forces. Now we will see what are the laws of motion. So first law of motion. First law of motion is related to inertia. It says that a body will remain at rest until some external force is applied on it, or a body will remain in its position of motion along a straight line unless some force is applied on the body. So this law is called first law of motion. Now second law. Second law states that resultant force in a direction or force applied in a direction is directly proportional to rate of change of momentum in that direction. Now you know what is momentum? The product of mass and velocity, that is known as momentum. So according to second law, force is directly proportional to rate of change. When we say rate of change, we mean to say d over dt, momentum, that is mv. Applied force is directly proportional to rate of change of momentum. Now it can be written as F directly proportional to, now m is a constant, you can write dv over dt. Now you know this equation dv over dt, that is rate of change of velocity. This is also known as acceleration, a. So you can write F proportional to ma, or F equal to kma. Now by various experiments, this value of k was found to be 1. That's why we can write F equal to ma. So this is a conclusion from second law. You can again revise. Second law states that force applied is directly proportional to rate of change of momentum in that direction, or we can say F equal to ma. This is second law of motion. Now the last one, third law of motion. Third law of motion says that to each and every action there is always an equal and opposite reaction. Now suppose I am standing on the surface. So surface is bearing my weight. Now according to Newton, or according to this third law of motion, surface will also exert a reaction on me in opposite direction. Just like this is a body of weight W, and this body is resting on this surface. So this surface will bear the weight of this body. Now, according to third law of motion, to each and every action there is always an equal and opposite reaction. So this surface will also exert an upward force on this body, which is known as reaction R. Okay. So this is third law of motion, that is, to each and every action there is always an equal and opposite reaction. So this is all about all the three laws of motion. In our next lecture, we will see how to draw the free body diagram of a body and what is the use of these three laws, first law, second law and third law. We will see the applications of these laws in our next video. Till then, thank you everyone.